The first material to be tested is glass wool. The initial smoke given off is the binder being burnt off. After 2 minutes, the smoke levels increase. After 5 minutes, the temperature has reached 770 degrees centigrade, at which point the glass wool tiles become dimensionally unstable, collapsing at 7 minutes. The glass wool test was stopped. The next material to be tested was a gypsum tile. The first reaction again is smoke development from the binders used. This is coupled with steam rising from water evaporating from the tile and condenses on the glass viewing panel above as water droplets. 2 minutes have elapsed and a temperature of 650 degrees centigrade reached. Like the glass wool before it, the gypsum tile loses its dimensional stability and at 7 minutes collapses. The flames have total access into the void above. The collapse is clearly demonstrated from below. The last material to be tested is stone wool. Like the two previous materials, glass wool and gypsum, the stone wool gives off a small amount of smoke as the temperature rises and the binders burn off. At the 7 minutes point in the test, where both the glass wool and the gypsum tiles failed, the stone wool tiles show no sign of losing stability. The test continues to a point where the temperature within the oven reaches 1000 degrees centigrade, and the elapsed time now stands at 20 minutes with no detrimental degradation in the stability of the stone wool tiles. The test is stopped. The stone wool tiles have remained stable and in situ, assisting in protecting the void and surfaces above. A very clear and visual testament to the added fire protection offered when using stone wool suspended ceiling tiles. This comparative test has proven the superior ability of stone wool to resist fire. We can see that the stone wool tiles have remained in place with the only visible change after 20 minutes exposure to fire being the change in colour of the grid system. To summarise the three tests, they clearly show that glass wool melts at approximately 600 degrees centigrade and, losing its structural stability, it collapses. Likewise, gypsum tiles, when exposed to fire, lose their structural stability when the water crystals within evaporate and also collapse. Stone wool, on the other hand, being made primarily from stone, maintained its structural stability, even when subjected to much higher temperatures and over a greater length of time.